Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on March 4th, 2026, just yesterday. It introduces a prompting technique called structure of thought, finding that explicitly guiding models to construct intermediate text structures boosts performance by nearly 6% across 8 different tasks. The paper is titled T2S Bench and Structure of Thought, Benchmarking and Prompting Comprehensive Text to Structure Reasoning. And as we'll see later, the results suggest that current models have a lot of room for improvement when it comes to structured reasoning. And for those interested in the implementation, the authors have shared their code on GitHub. To illustrate the impact, Figure 1 compares the new structure of thought method against standard prompting techniques across 3 model families. The chart groups 8 tasks into categories labeled Fuse, Find, and Form, with the vertical axis tracking performance improvement over a direct answering baseline. Notice the darker bars representing structure of thought. They consistently show positive gains across all models, including GPT-4o and Llama 3. In contrast, the lighter bars for standard chain of thought sometimes dip below 0, meaning traditional reasoning prompts can actually hurt performance here. To support these evaluations, Figure 2 details the construction pipeline for the T2S bench dataset itself. The process begins on the left with sample collection, where the team sourced academic papers across 6 domains, including computer science and life sciences, filtering them through rigorous human verification. The middle panel then illustrates how they generated multi-hop reasoning data, employing templates like fault localization to create questions that depend on structural understanding. Finally, the right panel shows the end-to-end construction phase, which focuses on validating key nodes and links to ensure the ground truth is accurate for structure extraction tasks. Well, Table 1 fleshes out the specific scientific domains mentioned in the collection phase. It organizes the benchmark into 6 primary categories, including computer science, life sciences, and economics. For each field, the right-hand column defines specific structural archetypes, such as model architecture diagrams in computer science or causal DAGs in life sciences. This taxonomy ensures the dataset covers a wide spectrum of reasoning patterns, from algorithmic flowcharts to physiological pathways, rather than relying on a single generic structure. So, while the previous table covered the topics, Table 2 defines the actual reasoning tasks within the benchmark. The authors organize these into 4 high-level categories of structural logic. First, fault localization challenges models to pinpoint issues, like identifying a bottleneck or a root cause. Second, functional mapping tests if the model can recognize component roles, such as which node acts as a router. Then there is boundary testing for edge cases, and finally, counterfactual reasoning. This last category poses hypothetical scenarios, asking the model to predict outcomes if, for instance, a feedback loop is disabled. So, while Table 2 defined the tasks, Table 4 now delivers the actual performance numbers for over 40 models. The central columns report accuracy on reasoning categories, like fault localization, while the rightmost section displays structure scores for node and link extraction. Gemini 2.5 Pro claims the top spot with an overall exact match score of roughly 81%, outperforming GPT 5.2 and DeepSeek R1. A critical insight here is the gap in the structure score columns. While models are good at linking concepts, node extraction remains a bottleneck, with even the best systems scoring below 60%. Okay, having seen the baseline gaps, Table 5 investigates if fine-tuning on the new dataset actually closes them. Here, we track QWin 2.5 and Llama 3.1 across standard prompting versus the new methods. Looking at the first columns for T2S bench, simply adding structure of thought prompts improves QWin's exact match score from roughly 29 to 41%. But the real leap appears in the highlighted bottom rows. Fine-tuning on the T2S dataset pushes that score to 46%, and significantly, these gains transfer to the external long bench and scrolls benchmarks on the right, boosting tasks like Hotpot QA. Wrapping up, 2 takeaways stand out. First, the structure of thought method proves that guiding models to organize text like a human reader by marking key points and connections consistently boosts reasoning accuracy. Second, the T2S bench evaluations reveal that even powerful proprietary models struggle with structure extraction, highlighting a major area for future improvement beyond simple context scaling. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.